This feels like a pretty simple thought experiment, right? But physics? Well, physics has other plans. And the real answer is way, way more catastrophic than you'd probably guess. So let's dive in. What would actually happen if our oceans weren't water, but this shimmering, deadly sea of liquid metal? So here's the question we're tackling. In a single instant, poof, every single H2O molecule in the sea is swapped out for an atom of mercury. Let's really break down what that world would look and feel like. Okay, first things first, let's set some ground rules. When we say the ocean, we mean all of it. Every single interconnected body of salt water. And turned into means an instant magical swap. No loopholes, no slowly adding it in. We're doing this the hard way because, trust me, that's where the physics gets really interesting.
All right, let's start with what you'd see first. The most obvious, immediate change is all about one simple property: density.
And look, the difference here is just staggering. Mercury isn't just a little bit heavier than water. We're talking about something that is almost 14 times denser. And that one single fact is going to change absolutely everything on the surface of our shiny new planet.
So, first consequence, extreme buoyancy. A giant supertanker would float like a little rubber duck in a bathtub. You could toss an anvil into this ocean, and it would probably just bob on the surface. And you, forget about swimming. The buoyant force would be so powerful it would literally shoot you out of the mercury like a cork from a bottle. You couldn't sink if you tried.
Okay, so floating is fun and all, but honestly, it's just a distraction from the real planet-sized problem. We haven't just changed the ocean's density, we've fundamentally changed its mass. And that is where things get truly catastrophic.
This is our starting point. That number on your screen? That's the weight of all the water we are about to replace. It's an almost unbelievably huge number, all on its own.
Now, here's the crucial move. We take that enormous mass and remultiply it by 13.6. This is not just adding a little extra weight to the planet. No, this is like suddenly strapping another, much smaller planet right onto our own.
And the result of that little bit of math? We've just plopped 17 sextillion kilograms onto the Earth's surface. To put that in perspective, that's like adding the weight of nearly 3 entire moons, instantly.
Now, while that might not look like a huge jump on a chart, believe me, that tiny fractional increase in total mass is more than enough to completely shatter the delicate balance of our entire world.
So what happens next? Well, all that new mass means a lot more gravity. The planet immediately starts to react to its own new crushing weight, and the results are not pretty.
Yeah, forget about those comically high-floating ships. At this stage, your concerns become a little more fundamental. You're not just dealing with a weird ocean anymore, you're dealing with a planet that is actively trying to collapse in on itself.
The chain reaction would be swift, and it would be total. First, the increased gravity would instantly compress our atmosphere, causing air pressure to skyrocket to deadly levels. Then, the crust itself would just start to fail under the new load, cracking and buckling everywhere. And all that pressure, it would shoot right down to the core, triggering massive, global earthquakes and volcanic eruptions like we've never seen.
We like to think of the Earth's crust as this solid, unmoving rock. But on this scale, with this much new weight just sitting on it, it would start to behave more like wobbly jello. The continents, the very ground beneath our feet, would simply fracture and sink into the mantle under the unbelievable weight of these new Mercury oceans.
But, as the world is literally ending around you, as you stop being biology and start being physics, there is another, even more pressing concern we need to address: the paperwork.
Okay, so yes, the planet's crust is shattering. That's a thing. But let's put that aside for a second because you've also just caused a pretty significant environmental incident. Every fish, every whale, all the plankton, they're all dead now. Acute mercury poisoning. And that, my friend, is a serious, serious violation of international law.
So, just to be perfectly clear, this is a bad idea. A horrible idea. Do I need to spell that out? I hope not. I mean, the environmental impact report alone would be an absolute nightmare. Unfavorable would be putting it very, very mildly. So, after exploring the floating ships, the planetary collapse, and the inevitable legal troubles, what's the ultimate takeaway from this entire thought experiment?
The conclusion is pretty simple. No, this won't work. Our intuition tells us this is a question about buoyancy, right? But the cold, hard rules of physics tell us it's really a question about mass and gravity. And gravity, well, gravity always wins. And once you really get that, you'll start noticing that same mistake in a lot of so-called science hacks out there.
And that really leaves us with a final thought, doesn't it? We just saw how replacing one liquid with another could literally tear the planet apart. So what other simple, seemingly harmless changes to our world do you think physics would turn into a complete and total catastrophe?